Hello, my name is Michaela Fullingham, and I'm going to be talking about the effects that pollen has throughout the Apis mellifera colony. So what is Apis mellifera? Why should we study it? Why is pollen health important to colonies? Apis mellifera is the European honeybee. This honeybee produces pollen and honey that allows for plants to be pollinated. Why should we study this? There's different types of pollination throughout plants. The more we study the pollen, the better off the honeybees will be. Pollen health allows for better offspring in plants, and it helps provide feeding the bees. So our research question today is, does the pollen quality affect the colonies within the Apis mellifera species? In the first experiment, there was thought to be a discrimination in pollen. However, during this experiment, one of the hypotheses that was formed was, does the pollen affect how Apis mellifera forages? During this experiment, it was determined that this was not the case. Apis mellifera did not forage based on the pollen quality, but rather what was best for the colony, gathering pollen. This experiment was conducted through entomologists to assess the different pollens based on the smell and fat extractions from pollen. Additionally, the entomologists also took into account the particle size of the pollen being foraged. Many of the honeybees preferred smaller pollen grains rather than larger pollen grains. However, many other factors were taken into account as well, such as the different types of pollen grains. The entomologists then took soy flour with differing proportions of powder from cellulose. It was concluded that foraging honeybees could not tell the difference between the two protein-rich grains. Lastly, the entomologists also set up a series of obstacle courses that the bees had to crawl through to retreat back to their colony. Many of these honeybees encountered a pollen that had that savory smell to it. However, when the smell was present, many of the bees selected this pollen. Overall, it was conducted that the Apis mellifera did not distinguish between the different types of pollen, the flowers that they come from. However, the honeybees determined the best way to forage for pollen rather than based on enriched protein that was provided for them. So this is a picture of the Apis mellifera bee with pollen grains on it. So there's different pollen quality throughout foraging. Determining how the pollen quality affects the species Apis mellifera can be a difficult task. But during this experiment, entomologists were able to conclude that the honeybee changes the way they collect pollen throughout the colony and may modify changes in the number of foraging bees throughout. In the experiment that was done, entomologists separated multiple colonies for about 5 days without no food, 5 days without pollen being collected. After the time was up, entomologists studied how the Apis mellifera bees would react to the lack of pollen. Through this experiment, one colony was given differing levels of high-quality protein and low-quality protein. Other colonies were either given high or low protein additives. Entomologists found contrasting ways that the bees handled the loss of pollen throughout those days, and they were given access to it. Some of the colonies were found to greatly increase their foraging rate to make up for the lost pollen throughout those days. However, their changes were within different types of foragers. The foragers with less experience were shown to collect more pollen than the foragers with greater experience. They stayed consistent. The results of the experiment were determined that the honeybee may modify the way they forage and increase their pollen count that they lost. Throughout the colony, many ways were used to combat the loss of pollen during this time. The honeybees would send foragers with more experience out to forage rather than the ones with less experience. In the picture on the screen, it is Apis mellifera foraging throughout the flower, Ovarian development with different flowers. So, with the protein given to developing eggs, the protein is known to encourage egg development and ovaries throughout the honeybees. Throughout this experiment, entomologists were able to determine certain types of flowers have the effect of growth through and with ovaries throughout the colony. Entomologists hypothesized that the effects could be caused by an imbalance in the protein and carbohydrate relationship when feeding on one specific flower. In this experiment, entomologists studied the effects of two different types of flowers, the sunflower and the aloe flower, with the growth of ovaries in honeybees. Throughout this experiment, it is seen that the honeybees feeding on the aloe plant were found to have substantial ovarian growth rather than the ones feeding on the sunflower plant. This may be due to the size of the grains fed to developing honeybees. Entomologists speculate. Throughout the experiment that was conducted in labs, there was different results for the honeybees. For example, the honeybee in the lab showed damaging results with the Apis mellifera species that was strictly fed aloe plant than those given the sunflower. This caused the honeybees to have an imbalance in their diet, thus resulting in a higher death rate. Entomologists then concluded that the flowers fed to the honeybees have differing outcomes, as well as in their growth. In this picture on the screen, it is Apis mellifera throughout the different stages of development. There's some eggs, there's also some larvae, and so on. So there's young bees and the effects that they may have on pollen. Pollen quality may affect the development of young honeybees. Entomologists conducted an experiment to determine if the developing bee could show altering development than those fed a different diet. Some of the eggs that were developing were fed a type of sugarcane and a type of pollen that was 1 year old. The other bees were fed bee pro, which is an additive for pollen, and some of the developing eggs were not fed anything throughout this experiment. Over the course of different days, development was monitored throughout the honeybees. What entomologists found was that certain honeybee glands and ovaries varied with what they were fed. However, the honeybees fed different types of diets showed significant increase in development within the ovaries, depending on their consumption of protein. During this experiment, it was found that 1 year old pollen did not have any effect in the development of those young honeybees. Here is a picture of the Apis mellifera with young honeybees, as well as with an old honeybee, probably a nurse taking care of those bees. So there's definitely adult bees with pollen nutrition. Pollen has the effect to allow for greater health for Apis mellifera honeybees. In this experiment, entomologists were able to determine the effects of certain pollen that bees consumed and how it affected them. Certain pollens had about 8% of protein to about 18% of protein. One of the pollen types used in this experiment was called Asteraceae. This pollen had little to almost no nutritional value to it. In this experiment, however, it was also determined that the relation of pollen content in pollen was not related to the ovaries throughout honeybees. Thus, entomologists were able to conclude that much of the different proteins being consumed did affect the survival of these honeybees. In this picture, you can see the honeybees consuming the different types of pollen that was brought back to the colony. In conclusion, many different types of pollen have certain effects on the honeybees throughout the different stages of development. Additionally, some pollen grains were deemed great nutritional value for Apis mellifera. However, some were not proven healthy for these honeybees. Why should we study this? With the advancements in science, many plants may be altered to produce different types of pollen. Therefore, we should keep studying the different types of pollen to have a better understanding of Apis mellifera and how the honeybees are affected by the different types of proteins and other nutrients within the pollen. Here's a list of my references throughout the presentation. Alrighty, thank you for joining me. I hope you have a great day. Thank you.